Hi, everyone. I'm Greg Bassett, Associate Director with the Global Automotive Practice at market research firm Strategy Analytics. In today's webinar, we will hear from both members and non-members of the eSync Alliance as they provide their perspectives on the topic of standardization as it relates to automotive over-the-air updates. The webinar will be divided into three major sections, beginning with commentary from our hosts and panelists, which will then be followed by a 25-minute discussion moderated by my colleague, Roger Longto, who is the Director of the Connected Mobility Service at Strategy Analytics. And then 10 minutes of Q&A, where panelists will answer questions submitted by attendees. Introducing today's topic will be Mark Singer, Chair of the Marketing Workgroup of the eSync Alliance. Following that, we will hear from our panelists, including Martin Bornman, Director of Systems Mobility Architecture Group at Aptiv, Steve Crum, Executive Director, Genivi Alliance, and Executive Vice President at Global Inventures, Jared Floyd, Technology Strategist, Office of the CTO at Red Hat, and Frank Lebussar, Director, Advanced Software Development at ZF Group, and member of the Board of Directors of the eSync Alliance. During our webinar, you'll be able to submit your questions via the chat field in the lower right of your screen, and questions not addressed during the call will be provided to panelists for direct follow-up. Also, all registered attendees will receive a link to a recording of the webinar. And now, on to the webinar. Mark?
Thank you, Greg. Greetings, friends and colleagues. I'm Mark. I head up the Marketing Workgroup of the eSync Alliance. I'll be providing a brief introduction, so those of you who may not be familiar with eSync or the Alliance may be brought up with the basic information to allow you to better understand the perspectives that will be offered as we go along. The eSync Alliance is a multi-company initiative formed to standardize a common platform for OTA updates and data gathering in the automotive arena. We welcome all participants in the automotive ecosystem to join us and participate in the activities of the Alliance. The eSync Alliance is based on eSync, which is a distributed architecture for OTA in the automobile. eSync has three core levels: the server in the cloud, the client in the vehicle, and agents for the devices in the vehicle. And it is a compliance-based alliance. And compliance to the eSync specifications means compliance with the architecture as we see, with the feature specs. At the right, you can see the core features of each of these levels of the architecture, and with the APIs, the correspondence between the different levels of the architecture. And when we have these three factors, then we have an interoperable environment where servers, clients, and agents can come from different sources and can be rapidly integrated into a data pipeline to reach from the cloud to the edge devices in the vehicle. The core values that this architecture and this specification provide in the automotive arena are addressing specific issues in automotive OTA. Number one, scalability. eSync can scale to any number of devices in the vehicle. It can scale across any number of differing vehicle configurations, and it can scale across geographies worldwide. eSync is highly flexible. eSync relies on policy-based over-the-air updating, policy occurring at several levels: policies in the server, policies in the complexity of the software, and policies for the individual agents for their individual devices, such that a braking controller may have policies that are more restrictive, either in security or what state the vehicle must be in before it performs an update, than perhaps devices in the infotainment or comfort group may have. eSync is highly adaptable. It spans all popular operating systems in the automotive arena. Server, client, and agent, the various components have been implemented already in Android, Linux, QNX, Integrity, AutoSAR, including classic AutoSAR, and a number of small RTOSs, including Erica and FreeRTOS as examples. eSync is bidirectional. You can do data push or data pull over the same pipeline. You can update devices and you can draw operational data from those devices. It is highly secure, and the security is multi-tiered. eSync secures in the server, in the cloud. It secures the link between the server and the client in the vehicle, but it also secures within the vehicle between the client and the agents. This providing security not only on a perimeter basis, but even compartmentalized security within the system. And perhaps the greatest benefit, eSync is standardized through the activities of the eSync Alliance. Now, eSync is not just a theoretical model. eSync is a commercial solution and is reasonably implemented. We already have 9 automakers worldwide who are deploying vehicles with eSync. Some metrics from that: we expect at this point now more than 13 million vehicles under contract in the various programs of these automakers. And in the terms of the scalability of deployment, the most complex vehicle, we have eSync reaching more than 60 devices in the vehicle. And scaling across vehicle models, we have one manufacturer now that is proceeding with their 5th model. They have, by June of this year, 5 models in 3 different model families. These with differing numbers of devices, differing models of devices, and even differing network topologies. And that manufacturer, just by way of example, began shipping their first vehicle with eSync only last summer. And by June of this year, we'll now have 5 models in 3 different model families. eSync volumes by the OEM geography, and here we're talking about where the OEM is located, not necessarily where the vehicles are, as in some cases these vehicles may be made for export markets. But we have OEMs in Europe, in China, and in Japan deploying eSync. The eSync Alliance has 3 levels of membership: adopter, promoter, and charter. The basic adopter level provides you access to the released specifications and test tools. As you move up, you gain access to pre-release specifications and increased activity opportunities within the work groups and even in the governance of the Alliance. So we welcome you to look into the eSync Alliance. We invite you to come and join us. And if you would like more information, you are invited to contact me at marketing.team@eSyncAlliance.org or our executive director, Mike Gardner, at mike.gardner@eSyncAlliance.org. With that, I will hand it now back over to our hosts, to Roger Langto, to move us forward into the panel. Roger, take it away.
Thank you very much, Mark. Without further ado, allow me to introduce Martin Bormann, Director, Systems Mobility Architecture Group for Aptiv. Martin's going to talk about eSync in the context of vehicle architecture and networking. Martin?
Thank you, Roger, for the introduction. So this is my 21st year with Aptiv. A lot has happened in the automotive world since that time, but since more than 4 years, we are developing holistic architecture vision for Aptiv, which is called the Smart Vehicle Architecture. I will explain a little bit what this is in the following context. So we have too many units in cars today. So up to 106 boxes have been found in cars, recently released to the market itself in luxury SUVs and others. So by far the functionality of cars is distributed in a way which is not acceptable for the future. So the complexity of the software development has reached a point which is not more or less manageable anymore. So the functional distribution has to be set up in a different way. That's addressed by Smart Vehicle Architecture. So it's first and foremost a concept for the integration of functionality into a much smaller number of boxes and processing nodes. So the number of units is very important because the interfaces in between the boxes are not manageable anymore. So to unite these diverse applications such as body control, user experience, connectivity, sensing, and advanced driver safety is very important here. So especially also in order to allow autonomous driving. So Aptiv has a unique portfolio in the market. We are on one hand addressing electronics, so by driver assistance, by user experience, body control, and other elements. But we are also addressing cables and harnesses. So the unification of these kind of applications is a holistic activity. So especially also if you really put all these elements into a context, into a single concept, that's very important to consider the entire vehicle. So you cannot isolate it to single domains or single units. You have to see it in a holistic context. That's what also SVA is addressing. So but the concentration of software into specific domains more or less enables a lot more sustainable software development and commoditization of software into individual software domains. And to offer a standard approach is very important here. So eSync is one of the elements in order to address a standard-based software development. This means operating systems, but also, especially here, this SOTA and FOTA solution needs to be standardized, that all these different software portions and units can interact in a much more efficient manner than it is today. So we need to transform the electronic development today into a sustainable future in order to allow a sustainable development, but also manufacturing, and to manage the cars in the field later on. So to have an after sales after the car has been launched today. If you buy a car, this car will stay as it is the next 10 to 15 years before you really put it into trash. The car in the future will be a living animal, and especially eSync is one of the most important elements here in order to have a standard-based approach to address these kind of manufacturing and but also maintenance in the field. Thank you very much for your attention.
Thank you, Martin. And now allow me to introduce Frank Libroussard, Director, Advanced Software Development, ZF Group, member of the Board of Directors of eSync Alliance. Frank is going to discuss eSync in the context of DevOps and digitalization.
Thank you, Roger, for the introduction. Hi, everyone, and welcome to this webinar. So if you would move to the next slide, please. So the software-defined vehicle is already a reality at ZF. Whether it is for advanced driving function or automated driving, for automotive safety, or for electric mobility, we need a connected car, a car which is connected to the external world. Why? Well, first, it's to achieve the functionality by itself. B, it's to capture additional information about the environment around us. 3, it's actually the opposite. It's to deliver information that we see to the environment. D, it's to be able to cope up with the regulation. Like, for instance, when you do automated driving, speed limits may vary, and we need to be able to address that. And then finally, we are committed to permanent improvement, and we want to add functionalities to our products. You can move to the next slide, please. The next generation mobility is promising, but it requires immense amount of engineering, and which is much more complex in nature and time consuming compared to the past. So yeah, if you remember, NASA sent a crew of astronauts last Friday to the International Space Station. So what is our go to the moon target for us as software engineers? Well, for us, it is to be able to deliver a bug fix in less than 24 hours. So this is a very ambitious target, and anyone who has been in the automotive industry understands that. It's not as easy as it sounds. But the first thing you need to do in order to achieve that target is to understand what is going on in the vehicle, not next week, but now. So it's a real-time data collection is the key point. Once you have that, then of course the engineers can work on the bug, solve it, fix it, and then they can go through full automation with the test requirements that they would build automatically, simulation tests, and ultimately they will release the software. And then, as the last hurdle, it is how to deploy that software into the vehicle. Once again, we can only do it with OTA. So OTA is really the foundational block to improve our efficiency and to reach this target. If you would move to the next slide, please. So why is standardization of the OTA pipeline so important? So if you imagine that everything I described before, we need to do it again for every OEM, then we are wasting time. And actually, all the promises of digitalization and monetization are void in that case. And there is no value to it, because the real value is in the functionality that we bring to the end user and the end customers. It's not in how we implement the OTA updates. So if you look at the data business, there are multiple ways where we can bring benefit to the end users by connecting the vehicle to the cloud. Using a standard technology, we can accelerate the data business. It's actually the enabler. Next slide, please. I'm going to take a very unusual example to illustrate the benefit of standardization. Let's consider a very simple device, a ball joint sensor. So it's a mechanical device. Now, if you add to that small mechanical device, a suspension ball joint, if you add a sensor and you connect it to the cloud, then you can define a whole new range of functions. You can do road condition monitoring. You can do payload weight monitoring. But that device is so cheap, so small, that if we have to redevelop all the time the connectivity for each OEM, each car range, the price of it becomes simply prohibitive. So the only way to actually deliver all of this is to be able to standardize basic features like over-the-air updates and over-the-air diagnostics to make it a commodity in order to address these commodities. Thank you very much.
Okay, well, yes, the ball joint may be cheap, but it's not cheap to replace. Thank you, Frank. Now let me introduce Jared Floyd, Technical Strategist, Office of the CTO for Red Hat, who will talk about eSync Alliance from a cloud perspective.
Thanks, Roger. It might seem a little out of place here looking at the other participants that all deep industry participation in automotive, delivering components that are in vehicles today. Red Hat, of course, is the world leading provider of enterprise open source solutions, which ranges from Linux to cloud native application platforms. So you might be wondering, how do we fit into eSync Alliance? The way that we see being able to support eSync Alliance is through the hybrid cloud backends that support all of the infrastructure necessary to have millions, tens of millions of vehicles on the road, receiving updates to these dozens of devices that are attached within the vehicle. So we're also today announced that we do intend to provide Linux-based platforms that will run in the vehicle, and of course that would naturally fit into the eSync platform for receiving updates for devices that are attached throughout the vehicle, as well as providing a cloud backend for supporting eSync servers. The eSync server is implementations are already a cloud native containerized platform that allows for flexible deployment across a variety of public cloud platforms, as well as running in automakers or system integrator data centers, all being able to use the exact same software running on the exact same Kubernetes-based platforms. So that's really exciting. And the really interesting thing to us is about the changing in vehicle platform. Mark mentioned that a modern vehicle may have as many as 60 different compute devices, ECUs, that are providing services all the way from the sensor monitoring that Frank talked about for, say, load monitoring, preventative maintenance, being able to feed data back up into the cloud for analytics processing, and then much more complicated systems providing, say, infotainment services or advanced driver assistance systems. Throughout the vehicle, these systems need updates. And what's changed fundamentally are with the connected vehicle, there's a need for security updates that touch many of the ECU components within a vehicle, continuous security updates, as well as the expectation of continuous functional updates. No longer is a car static and frozen in time when you purchase it. that there's the expectation from the driver that major new functional experiences will be delivered throughout the life cycle of that vehicle. To deliver that sort of life cycle experience, a robust and complete update system is necessary, not just for, say, the main Linux-based ECU, but also the dozens of other systems within the vehicle that support all of that functionality. So we're really excited to be able to be a part of that solution and to provide an open source platform that can provide both a server backend for maintaining the infrastructure for updating these millions of vehicles on an ongoing basis, as well as the future opportunities in vehicle to support updates via the eSync standards. Thank you.
Thank you, Jared. Yes, our cars are driving in the cloud these days. Now the last perspective before we get into our Q&A will come from Steve Crum, Executive Director of the Genivi Alliance and Executive Vice President for Global Ventures. And Steve's going to talk about eSync from the perspective of data formatting and standardization.
Yeah, thanks a lot, Roger, and thanks to the eSync Alliance for inviting me to join this panel. I'm not going to have any slides to share, but you're all smart people, and so hopefully you'll get what I may be able to share here in the next few minutes fairly easily. Before I get to the data standardization and gathering topic, I just wanted to talk real plainly about the importance of collaboration. Two organizations are almost always better than one, and sometimes three are even better. And this is the sort of mantra that organizations like Genivi and eSync Alliance abide by. And it's not just because it keeps our lights on, but because we believe that standards delivered by a collection of stakeholders has a better chance of saving time and money in future programs than one-off solutions that have to be maintained forever. But let me add one thought on top of that. We often think of the necessity of collaboration within a standard body like eSync Alliance, but I've become convinced that to truly impact the industry, to reduce complexity, to save time and money, standards bodies must take on that same mentality of working together that we expect our member organizations to exemplify. We all know that vehicle systems are no longer one operating system plus a bunch of functions. They're a bowl of spaghetti of different systems, sharing resources, honoring safety boundaries, and architected in a way that allows for portability and new software-defined functions, as Jared said, that become available to a vehicle already off the dealer floor and on the road. And it's no longer just an OEM and supplier figuring it out. It's standards bodies engaging together to make sure their standards and approaches actually piece together in an efficient way, so that integration isn't a costly and time-consuming nightmare. And so this is why Genivi, in collaboration with the W3C, has launched a new initiative called the Common Vehicle Interface Initiative, or CVII. And Genivi is pleased to repeat an announcement made last week that Genivi and the eSync Alliance have entered into a formal liaison relationship. And this relationship allows our technical teams and our joint members to discuss our respective technology deliverables and how they can actually work together in the context of CVII and in current and future vehicle software programs. Genivi has been working with W3C for several years on vehicle data standards and vehicle-to-cloud communications. And among other things, that collaboration has produced the Vehicle Signal Specification, or VSS, that has become a primary candidate for an industry-wide standard data model for both in-vehicle signals and for data transferred and analyzed in the cloud. eSync Alliance has a data gathering approach that Genivi believes should be explored for synergies with this data standard. And the liaison relationship established will allow us to do just that. eSync Alliance is also well known for SOTA technology, as you've seen in the previous presentations. And this dovetails with another development within Genivi, a standard vehicle service catalog for describing services like SOTA and many others in a standard way. Part of our collaboration with eSync Alliance will also look into describing their SOTA service in the vehicle standard catalog. And finally, Genivi is a very software-driven organization, and we are actively producing proofs of concepts in a variety of in-vehicle, vehicle-to-cloud, and in-cloud contexts. And we believe that portions of some of the implementations of eSync specifications could speed along some of those proofs of concept we are considering for vehicle data gathering. So that's just a quick tour of the new relationship between Genivi and eSync Alliance and three areas that we will be looking at together. From my perspective, we need to see more of this alignment between organizations, which is why Genivi, W3C, and now the eSync Alliance are collaborating in this common vehicle interface initiative. We look forward to eSync Alliance playing an active role in CVII going forward, and we look forward to benefiting from the good work that they've already done. There's a lot more work to be done to align outputs from organizations also in the space, including AutoZar, Sensorus, ISO Extended Vehicles, and many others. And I encourage those listening on the webinar today who are in positions of influence in other automotive bodies to consider helping to align those outputs from these and other organizations in the spirit of getting our standards to integrate simply and at a reasonable cost of time and money to OEMs and suppliers who are adopting those standards. So with that message, I want to thank again the eSync Alliance for the opportunity to talk today. I look forward to a technically productive relationship going forward between Genivi and eSync, as well as a number of other alliances and organizations in this common vehicle interface initiative that we are pushing. So back to you, Roger. Thank you.
Thank you very much, Steve. Yes, I want to call it a thankless task, but I think there are a lot of rewards in pursuing collaborative activities in the automotive industry, but it can be, I'll say, challenging at times. But anything that is worth doing may not always be the easiest thing to be achieved. To kick off this conversation, and by the way, we have one question. We have two questions already in the Q&A, so clearly our listeners understand how to post questions, and we will do our best to get to those Q&As from the listeners. And I'll try to move quickly through the questions that we have scripted out here somewhat. So what are the opportunities inherent in standardizing OTA technology? You know, saving speed to market, security, supply chain management. We've talked about a lot of these things, but Jared, what are your thoughts on this?
Well, I think Steve really touched on this at the beginning, which is the opportunity for collaboration, because collaboration lets us all work more quickly to deliver more. If you look at supply chains in the automotive industry, they're quite deep, both hardware and software, and that means there can be a long lag time to market with new functionality. The car that you're driving today may have technology for the in-vehicle electronic systems that was designed and delivered 5 years ago. And when you look at the rate of change that the average consumer expects of, say, the interface they get from their mobile phone, and how quickly new technology developments are then delivered to that mobile experience, that same expectation exists for in-vehicle interfaces now. And the only way to deliver that constant functional update and that rapid time to market from technology innovation to in a vehicle on the road is through the collaboration that open standards allows.
Frank, do you have some thoughts on this question, collaboration?
Yeah, the first thing I would like to say is probably exhaustivity. When we have various members in the alliance, or when we work in combination with other organizations like Genivi, we bring different focus, we bring different value, and then we can build a better system. So for instance, in the eSync Alliance, we have tier ones, but we have also manufacturers of test equipment, for instance. So we are building a complete ecosystem. The second point is compliance. There are lots of, I would say, regulations that are coming up, like the UNEC WP29. By contributing to a standard and by adopting a standard which is already compliant, actually you benefit from you get a very quick start on your market. It's also in terms of competition. So when we have a standard, we create an open competition between different vendors, which increase the freedom to select products that are compliant to the same specification. A bit like our goal is really like VUDS, to have very interoperable modules, like the cloud part can be provided by one vendor, and then the client part in the vehicle can be provided by another vendor. And both of them are interoperable. If you bring multiple companies in this, then you are able to really create that interoperability. And then finally, I would say all the savings when you go to avoiding reinventing the wheel. You can focus your teams on developing what really matters for our product range. So for ZF, we focus on CO2 reduction, we focus on autonomous driving, advanced driver assistance, and we don't focus so much on how to do the over-the-air update, which brings no value to us. We just take a standard and we save time, and we can contribute to that standard. That's also the other key part. It's not we take, it's we can contribute. For instance, autonomous driving or ADAS, you need to have usually multiple cameras, multiple radar, you have high-end computers, and when you do an update, you need to update all the devices of the subsystem together in one transaction. This is typically a requirement that we bring. When you want to do an update of a braking ECU, you don't want the vehicle to be driving, for instance. You want the vehicle to be stopped and in a safe position before you do the update of the brakes. So all this kind of requirement that we bring and that every participant bring just contribute to make the standard better and more secure.
Yeah, I think we're constantly struggling with speed to market and the product lifecycle management issues. Martin, some quick thoughts from you on this?
Yes, I can only agree on what has been said. For us, it's important to follow standards in order to really delete complexity out of the developments. Developments in the OEM range have been so expensive in the last years, and the cost will grow. So at least wherever possible, we have to avoid proprietary solutions. We have to follow standards, and especially the way how eSync is following a kind of an open API approach. It even enables a kind of a competition in the market. It's not a one-shop, one-stop solution. It's an open solution, and allows also everybody to compete, but at the same point of time to follow a standard. So therefore, that was the most important one for us, also to be part of the eSync Alliance, to contribute to a real open standard, but allows really also a kind of a competition in the market, that we don't have one partner, one company solution here, because that was there before and nobody made it really good experiences with this.
Now, there's no free lunch. What are the cost implications of employing eSync? Frank, do you have some thoughts on that?
Well, that's a good question. So I see multiple areas. The first one is obvious. It's in engineering. I would say you can save money if you adopt a standard. So it's in that case, it's not really a cost. It's more a cost avoidance by being able to quickly adapt something, a running solution. The second part is the cost of the hardware, and eSync is a pure software play. So as long as the vehicle is connected to the cloud, there is no real overcost to run eSync in the vehicle by itself, because the requirements have been developed in such a way that we can not only deliver the best value to the future ECUs, but also consider the legacy ECU with small hardware, with small microprocessor. And we have built the standard with that in mind. And then finally, there is a licensing of the technology. So obviously, it will vary from vendor to vendor. But here, as we encourage as many parties as possible, we believe there will be a good competition, and the market price will very quickly come to something which is fully acceptable to the industry. Obviously, the fast adapters are the best place, of course.
Mark, did you want to add anything? Uh-oh, are you muted again?
There we go. Sorry about that. I think that Frank has touched on it beautifully. The model of cost in the savings of the engineering effort, but also the encouragement of competition within the standard and the opportunities to focus engineering resources on adding value on top of the standard rather than on simply reinventing the same pipeline again and again and again will bring cost savings not only to the individual implementation of an OTA pipeline, but across the base of the industry as the same efforts are not repeated in multiple places at multiple times.
And can we get just quickly some examples of maybe some success stories, although I know it's early in the life cycle of this solution, but Martin, you have any thoughts, a success story, an example?
Yeah, so what we did a prototype implementation into existing ECUs. We wanted to test eSync, how easy it is to up integrate this into existing code. And I can only say it was very easy. And it took a very low time and also really low number of resources to up integrate the client and agents into our existing software. So we made very good experiences with that one and could create a running solution in a very short time frame.
Jared, a quick example?
Yeah, absolutely. So on the server side, we've been able to, with our partners at ZF, deploy the eSync server into a cloud environment running on Azure on top of OpenShift, and that provides the portability to run eSync server in any of the public clouds as well as in private cloud or edge environments as needed. So we found that eSync server runs seamlessly on top of OpenShift as a cloud-native application solution built on Kubernetes.
Now, Frank, what's the old line? Standards are so great because there are so many of them. What are the relations between eSync as a standard and other standard-setting bodies and regulations?
I think we already discussed the relationship with Genivi, and we already said that there is value in collaborating with between bodies, but sometimes some standards are regulations, like the UNEC WP 29 is something that that we have to follow. So I'm at the level of eSync. What we do is we work to make sure that our standard is compatible and it will enable all the all the adopters of our technology to be compliant. And I think that's a great start for somebody who wants to get an OTA solution, because they don't need to become experts in WP 29. We have done the work for them, and they are quickly in the matter.
Steve, do you have a quick comment on the other related standards and regulatory activity?
I think that the goal for the automotive industry should be to influence regulations through real life standards that are being produced by the people that are by those that are putting that software in the vehicle. I mentioned earlier that the eSync Alliance has become an important body in this common vehicle interface initiative, and I think we just have to get past this notion of standards bodies being able to develop standards and throw them over the wall and expect them to be adopted, but instead be more proactive in the development of those standards to architect them in such a way that it eases integration and it eases adoption, and it eases the ability for them to work with related standards, and that's what Genivi is trying to do in the vehicle data context, is with eSync and with other organizations, is to look at a standard data model and say, how can we make this easily adoptable in the context of other standards and other standards bodies? And what can we do today as we're building this out and as we're gaining adoption to make it easily digestible and edible by OEMs and standards adopters? And so I think that the relationship that we're building with eSync is sort of a prototype of other relationships that need to be established broadly within the automotive industry across all lines of standardization and functionality, not just in the data space, but in the web space and in the cloud interaction space. And so I really hope that we see a lot more working together between standards bodies in the future in developing standard solutions.
We have quite a number of participants listening in, and we do have quite a number of questions. So I'm going to shift gears a little bit and go to some of these questions since we do have quite a number of people. So people are engaged, they are interested in what we're talking about. So here's the first one. I'm going to send it to you, Martin. So eSync gateway updates other ECUs over CAN. Is it eSync? Is the eSync spec based on UDS-based update?
I think eSync allows different ways in order to contact, also to gather the data and to update the units. So it can be done via several different protocols. It's not only UDS, it's several different ones. Can be done via Ethernet, can be done via CAN, LIN. So the connection and the protocol is not fixed here.
Okay.
Can I answer?
By all means, Frank.
Yeah. So in eSync, we are trying to make the transition easy from the previous vehicle architecture to the new vehicle architecture. So we support the UDS-based update, but to get the full power of eSync, we have a specific agent that can allow a full end-to-end security even within the car. So I'm not just between the cloud and the car, but once everything has reached the car, then all the communication inside the car is also fully secured and fully protected. But we support both. Yeah.
Mark, this is clearly a question for you since this comes out of your slides. eSync mentioned they have 12 million vehicles in play in Japan, EU, and China. What about the US? I think that was vehicles in the pipeline. Well, what about the US? Yeah, Mark, what about the US?
Yes, unfortunately, adoption has not been quite as quick in the United States as it has been in other territories. But we could certainly look forward and hope to see more adoption in the United States. There are vehicles with familiar American brand names that ship in other parts of the world with eSync. But to my knowledge, at this point, no programs for consumer autos in the United States using eSync. None available that I could point to on our streets.
Okay, Martin, I'm going to try this question on you. What is the typical time frame from commitment to eSync and delivery in the form of production, start of production rollout for a typical OEM?
So a typical design times is about 3 years from starting of the development before you really bring it into the field. I would guess also the eSync implementation can be done in that normal cycle if you start a new development from before it really touches the market. So eSync will not delay the typical introduction of a new product into the market. It will enable us also to launch in time.
And here's a question, I'll send this one to you, Frank. To make standard in OTA, OEM's movement is most important. What could lead OEMs to use standard OTA in their end-to-end thinking? What about software service provider? What could be the most powerful incentive in the short term? Anyway, they need to change legacy systems to the new standard one. What are your thoughts or response to that combination question statement?
A lot of questions. Maybe I will start by answering to the last one. Anyway, they need to change legacy system. No, I just explained that we have built eSync in a way to be able to manage as well the legacy system. So that's the first point. Now, when it comes to OEM, today 6 OEMs have already embraced the eSync technology. They have it in their car, and one of them is part of the alliance as well. It is not mandatory for an OEM to be part of the alliance in order to be using our standard. You only need to be part of the alliance if you want to contribute to the specification, or if you want to develop and market your own eSync compliant solutions. Now, when it comes to the incentive, obviously, when the OEM is pushing for a standard system, they get as well reduction on their own development. Because if they push for a proprietary solution, as I said before, we will need to redevelop as a tier 1. We will need to redevelop all the OTA interface a second time, a third time. We will need to do a lot of validations, and this will in the end cost much more money to the OEM. Plus, there is the interoperability issue. When a car is not made with one single supplier. If you have 60 ECUs in the car, the likelihood that you have more than 40 suppliers for the 60 ECUs is very high. So you absolutely need to have a system which is guaranteed to be interoperable. And that's what we're doing with eSync.
Okay, I'm going to shift back to our standard questions, although we still have some questions in the audience Q&A. So, Steve, what are the nature of the data opportunities? We're hearing a lot about data monetization, but what kind of data in particular is the Genivi initiative focusing on? This is obviously a core value proposition implicated by the eSync Alliance.
To your point, the industry's been talking about the value of vehicle data for a long time, and I frankly don't think it's even close to seeing its full potential, and it won't until the industry begins to commit to a single language of looking at modeling and storing data, both in vehicle and in the cloud. And the two-way data flow that eSync is enabling, it has the potential of unlocking all kinds of potential for service-based delivery on vehicle data that's been analyzed in the cloud. You see examples of that vehicle to cloud interaction with things like speech recognition improvements in the vehicle through cloud interaction. That's something that requires rapid two-way data exchange. In Genivi, we're working with the Open Insurance Network to explore new models of insurance being delivered to consumers based on vehicle information. We're working with payment organizations like MasterCard, Visa, and Discover on how to look at vehicle exchange or vehicle data exchange and in-vehicle payment and in-vehicle commerce. And we're even exploring some things with EV chargers and power companies about how data flows from EVs through charge points to the providers so that they can better manage their grids and so forth. And so there's a huge amount of potential here, but it really has to start with a standard model for vehicle data that is, by the way, extensible to include legacy and pre-existing data approaches within OEMs, but also an efficient way and standard way of exchanging data between the vehicle and the cloud. And I think that's something that eSync is really working well on.
So Frank, Steve's certainly talking about certain kinds of data, cloud-based applications and things of this nature, but isn't it really all about predictive maintenance?
Yeah, predictive maintenance is always the...
Something about that ball joint, but go ahead.
Yeah, predictive maintenance is always what we bring forward as a main value, but there are lots of additional values that we don't speak about. Ball joint sensor, I spoke about road condition monitoring. If you get the information that one vehicle passed over a pothole, that's a good information. But now if you get the information that 500 vehicles passed over the same pothole location in the last hour, then all of a sudden the data becomes very accurate. And so from data connectivity, you can get much more value if you start to combine it by big numbers. You can also provide additional services like deriving other information. What about weight monitoring, for instance? That was the other example. You can reduce the engineering costs because you understand what is going on during your development, and you can speed up your development. You can get a faster resolution of problems. You can also incentivize. Like, you know, it's very popular at the moment to go for CO2 reduction, but how to do it, right? Many hybrid cars are in the market. How can we make sure that people are using really the electric drive when they are in the cities and not the petrol engine, where they would create CO2? So we can be coercitive and we can shut down the petrol engine and switch automatically to electric, or we can have more interesting approach with like, I don't know, gamification or incentivization. When you connect the vehicle to the cloud, you can get all this and you can extract data and you can create a bidirectional connectivity. You can actually unleash a large number of possibilities that we just start to think about. Predictive maintenance is just the most evident one, but there are many, many other possibilities that are blooming up.
Martin, a question for you. How important is it to be a part of the eSync Alliance right now? I mean, there must be a dozen OTA solutions in the market. What's different about eSync Alliance?
Yeah, so we for sure we scanned the market before we joined eSync to understand what kind of solutions are there. There are not so many standards, so there are a lot of proprietary solutions. And for us, it was important to be part of the standard body here to define a solution which fits to all areas of the car, which fits into all situations where we need OTA. So in the complex ECUs, like Frank had also have shown it before, a very simple ECUs, that we will get a solution which fits into all different areas of a vehicle architecture. That was one of the important points for us to really join eSync, to be part of that organization, because it addresses all different areas, all different ECU kind of solutions here, which are necessary to build a whole car.
Greg, do you want to do the last few Q&A questions?
Very happy to do that. We have a number, so we'll get through as many as we possibly can. The first question is until eSync agents are, or first question in the next series, until eSync agents are available in remote, smaller ECUs, presumably in a vehicle, how does the eSync spec bring standardization to the update workflow? Is it related to download and orchestration only, or other than that as well? So there's a question around what about the smaller ECUs in vehicles? How does it work with that? Less powerful ones where an agent may not be available. Mark, or anybody who may want to talk about this particular issue.
Sure, I'll take a quick pass on that. The concept of the eSync agent, the agent is present for the device, but that does not necessarily mean that the agent is embedded into the device. So often when we are dealing with legacy devices or devices that are very thinly resourced, the agent for that device may be external to the device. It may be in a domain master ECU or even in a zonal local controller that has no domain specific function, but provides the ports for the bus on which that smaller ECU or sensor may lie. So this is a working model that's used in deployments in many cases that the larger or more modern ECUs may have their agents embedded in them, and the legacy ECUs or the ECUs more thinly profiled will still have agents, but those agents will be external to the device, located somewhere nearby on the network.
Okay, all right, let's see. The next question is, I understand the significance of standardization when OEM 1, a car from OEM 1 interacts with another car, say an OEM 2 from OEM 2. But how does OTA standardization bring value when we have two cars from the same OEM that have OTA updates. Since there are proprietary solutions being used by the say OEM with similar update mechanisms. So it's what the question sounds like is if you have proprietary multiple types of OTA update solutions being used by the same OEM, is there any value in terms of having standardization for that OEM?
I can take that one, even though it's not so much a cloud platform, but it ties in, which is that the value is not so much communication between two different vehicles from different manufacturers. It's the benefit of standardization for that manufacturer across multiple models, multiple products, not having to operate multiple different cloud solutions to be able to maintain the update life cycle, which may extend for 10 or more years for all the vehicles that they have on the road. That having a single OTA infrastructure that's entirely cloud hosted and portable means that that OEM is able to maintain a single set of infrastructure to maintain security updates as well as functional updates across all of the vehicles that they produce.
Mm-hmm. Okay, on to the next question. So could you please explain in a few words what you consider the cybersecurity risks and process from performing software updates, EC communications, et cetera? So just a simple overview of cybersecurity risks.
I can take the answer for that.
Mm-hmm.
So of course, in terms of process, we follow all the state-of-the-art TARA analysis and this kind of thing. But in principle, cybersecurity starts when the tier one delivers the software to the OEM, and then this software is fully signed and encrypted. And when it reaches the cloud of the OEM, it is fully verified. So they're using certificates, and once the vehicle connects to the gets live, the first thing the vehicle does is it connects to our cloud. So it's not a push. It is a pull. So the cloud never talks first to the vehicle. It's always the vehicle taking the initiative to talking to the cloud. And then there is an exchange of the actual configuration sitting in the car and the actual configuration that is supposed to be in the car. This allows, for instance, to detect unwanted changes when the vehicle was offline or uncontrolled by the OEM. If somebody has made a change outside of the OEM control, I remind everyone that the OEM is responsible for the content of the car. So it's important to understand if something was tampered with. Once the vehicle requests the download of a new software, then that software is again signed, it is encrypted, and it is as well compressed. And the compression is made of a delta. So what we do is we know what is the software in the vehicle. The vehicle has told us, I have software version 1.0, and we want to send software 1.5. So we build a delta between software 1.5 and 1.0, and we download that delta. And then that delta is what will be rebuilt into the ECU. This allows for fast communication, but also for cybersecurity, because you need to know what was in the car before when you use Delta. Once the software has reached the vehicle, then it is, of course, verified for certificate, and it is then moved to the end ECUs, and again, end-to-end signatures and verification, all the way between the client and the agent, to make sure that even on the CAN bus, the software is not tampered with. And finally, there are reports all the way back to the cloud. And for the diagnostic, this is the same. All communications are fully encrypted and verified using the latest technology with X509 certificate, TLS, etc.
Okay, Greg, thank you, Frank, and thank you, Greg, and thank you to the rest of our panelists. Let me wrap things up here. So questions not addressed in the call will be provided to panelists for direct follow-up. All registered attendees will receive a link to the playback of the call and to a white paper prepared by Red Hat and eSync Alliance member companies, including XL4. So again, thank you panelists and thank you audience members for attending this session, and good luck implementing eSync solutions in your next OTA solution. Thank you.